Hey folks, let's take a look at example 5. So we're going to find the equation of an exponential function, and we've got everyone's favorite, a word problem. All right, so let's read. A wolf population is growing exponentially. All right, that's a good phrase to keep in mind. So as soon as I see that, I'm looking at y equals a times b to the x. Or if I want to be fancy, because we are in college algebra, I'm going to say f of x equals a times b to the x. Okay, so it's growing exponentially. In 2011, 129 wolves were counted. By 2013, the population had reached 236 wolves. So as I see this, right, in 2011, there were 129 wolves, and by 2013, there were 236. That shows me the wolf population is growing, right? That's what it said here. It didn't say decaying, it said growing, which is just a little kind of clue that whenever I find this number b, it should be larger than 1. Anytime you have exponential growth, b is going to be greater than 1. If there's exponential decay, b is going to be less than 1. And if we're at equilibrium, we're neither growing nor decaying, then b would equal 1. Okay, so this says, what 2 points can be used to derive an exponential equation modeling this situation? Excuse me for a sec. I don't know what got in my throat. Write an equation representing the population n of wolves over time t. So eventually, at the end, I'll change this to the letters n and t. For right now, I'm just going to keep f of x and x, but I'll switch them over to the letters asked of me. No problem. I'll just do that at the end. In terms of the two ordered pairs, I hear time 2011, 129 wolves. Time 2013, 236. So I'm going to show two ways to write this up. I could write 2011, 129, and then 2013, 236. And that would be fine. The only issue I take with it, and it's not really an issue, I want to be clear, this would be totally fine if you wanted to solve for a and b. It's just going to make your life a little bit harder because these numbers are so large. So there's kind of like a hack we do in math where whatever your lowest year is, and in this case it's 2011, we set that year to 0. We say that is year 0. That's our origin story. And if 2011 is year 0, then 2013 is year 2 because it's 2 years later, right? So 2011 is year 0, 2012 is year 1, 2013 is year 2. And what that does is it just makes these numbers a lot smaller, right? So instead of 2011, I have a 0 here. And instead of 2013, I have a 2 here. And since these numbers are so much smaller, when we plug in to find a and b, it's just going to be that much easier. Okay, so I typically, once I get my two ordered pairs, right, that's all I'm going to need. If I have two ordered pairs, I can find a and b respectively. And the nice thing is because this is now a 0, we can spot a right away. But let me just show you mathematically what I'm doing. I'm saying if I plug 0 in, right, we know f of 0 is 129. But you also know f of 0 is a times b to the 0, right? We know that is 129. But b to the 0 is just 1. So what we're saying here is that a is 129. So if you ever have an x coordinate of 0, whatever the corresponding y value is, that's your a. So at this point, right, here I am, I'm saying I know f of x is 129 b to the x. So I always use the ordered pair with 0 to spot my a value. That just makes my life a little bit simpler. And then I'm going to use the second ordered pair. All right, 2 and then 236. So I'm going to write 236 for f of x, and I'm going to write 2 for x, right? Because when I plug in, when x is 2, f of x is 236. So I'll put a 236 here, a 2 here, and then I'm going to solve for b. So when I go to do that, right, when I say 236 equals 129 times b squared, I have a quadratic equation. And you could use a quadratic formula if you want, but this, because it doesn't have any other linear terms, right? This isn't saying like 129b squared plus 2b minus 1. It's just 129b squared. It's faster to just isolate the b squared term and go from there. So what I mean by that is I'm going to say b squared, and actually just to be clear, I'm going to divide both sides by 129. And I like to write the variable I'm solving for on the left side of my equation. So I'm going to have 236 out of 129, right? And then I'm going to go to my calculator and crunch that number. And when I go to my calculator to crunch that number, I'm going to keep as many of those decimal points as I can. So I'm going to write 1.829 down here on my paper, but I'm going to keep that number with all of those decimal points in my calculator, because the sooner you round off, especially with exponential growth or decay, the less precise your answer is going to be at the end. So I'm going to put 1.829 here, right? And then if I want to solve for b, I'm going to take the square root of both sides. And when I take the square root of both sides, right, I would get that b was either the positive or negative square root of 1.829. And I'm going to opt to take the positive square root, because when we're talking about exponential growth, b is going to be a number greater than 1. But if I take the square root of that answer, all right, so of this previous answer, and just to remind you, I'll scooch this up, the answer key is over your negative key, and it's in blue, so I need to hit second to activate it. So I'm going to take the square root of that answer, and I'm going to get that b is either plus or minus 1.353. But again, I'm going to choose the positive root. So ultimately, I'm going to have b equaling 1.353. And this decimal right here, if we just kind of want to break this down, just to give you a for instance, I could write this as 1 plus 0.353. And the reason I'm doing that is if I think about this decimal as a percentage, this is about 35.3%. So what's happening to the wolf population from 2011, where we had 129 wolves, let me move this over here, to 2013, where we had 236. The wolf population is increasing by about 35% a year. So let me just take a little note here. It's not vital for the question, like to get the answer, but I just want us to kind of break down exponential growth, right? If your b was 1, that's static. You're neither growing nor decaying, but because of this extra number, because b is actually greater than 1 by 0.353, which as a percentage is 35%, the growth rate for wolves is 35.3% per year. Growth rate for wolves is 35.3% per year. Okay. But we're getting close to my end game answer, because we know our a value, and now I know my b value. So I can write an equation representing n, the number of wolves, over time t. So let's just substitute back to our original right now. So I'm going to say f of x is 129 times 1.353 to the x, right? And because, again, that base is larger than 1, this is exponential growth, but I can convert this now to the letters they're asking of me, right? I can say n of t is 129 times 1.353 to the t. And then typically what will happen after this, after you get your exponential model, is they might say something like, or you might be asked, what's the wolf population in, let's say, 2015, right? Well, in 2015, that would be 4 years after 2011, so I could plug in a 4 here and find the wolf population, right? If it was 2016, I would plug in a 5, get the wolf population. So now this is just a function of t. Once you find a t value, plug it in, get the wolf population. All right, thanks so much. Bye.